So I've put up the slide and the video recording address and the meeting note. So in case you guys want to went through it. And the KubeCon EU next year, CFP, will deadline on January 29th, something like that. So please remember to propose something around policy. Erica and I have thought about propose one on the policy as a type system. So if you have other interesting ideas, more than welcome to propose them. So as usual, shall we have like working group intro and deep dive session, or just one session to concentrate?
I think it probably depends more on what other people are interested in rather than what we would like, if that makes sense.
Yeah. I think maybe just one session might be good enough.
Probably.
Yeah, I observed like Sigolf intro and deep dive session also like spread thin. So could be better just have one session. So anyways. Okay. Okay, today I invite Xingyang from Six Storage to give a talk, just like overview of the policy in the storage land. Xing, do you have like slide or you?
Yeah, I have a
Okay.
few slides.
Okay, can you share?
Yeah, I can share. So should I start now?
Yeah, go ahead.
Okay. Hi, I'm Xingyang, contributor in Six Storage. So I'm talking about the storage policies in Kubernetes. I'll be talking about existing policies for persistent volume and volume snapshot content, and also some of the things we are thinking about for the future. Persistent volume has the reclaim policy. So this policy tells the cluster what to do with the volume after the PVC is deleted and the PV is no longer bound to the PVC. There are 3 policies. The first one is retain. Basically, when the PVC is deleted, the PV will not be deleted if it's retained. And admin can decide what to do with it later. Admin can delete the PV, but keep the volume on the storage system. Admin can remove the data from the volume later. Admin can also create a new PV for the volume and make that available to be claimed again by a new PVC. And the second policy is delete. That basically means when you delete the PVC, the PV and the volume on the storage system will be deleted as well. And delete is the default policy for dynamic provisioning, and retain is the default policy for static provisioning. And then there is the third policy, which is recycled, basically meaning when you delete the volume will be scrubbed. So the volume actually can be reused again by another PVC. But this one is deprecated, so I'm not going to talk too much about it. So this is how the reclaim policy looks like in the API. The storage class has this reclaim policy field that you can specify. And this field will be passed to this persistent volume spec. And the control persistent volume reclaim policy field and decide what to do with this persistent volume. So if it's deleted, then this persistent volume will be deleted. If it's retained, it will be left alone, and admin will handle that at a later time. And this basically shows the details of a PV. So here we have reclaim policy set as delete. And for volume snapshots, it's very similar. Volume snapshot content, this is the snapshot provisioned on the storage by the admin. This is very similar to persistent volume, which is storage provisioned on the storage system by the admin. And then we also have a volume snapshot API object, which is the request from the user for a snapshot. That's similar to the persistent volume claim concept, which is a user's request for a volume. So for volume snapshot content, we have two policies. One is retain, one is delete. Delete is for the default for dynamic provisioning, and retain is the default for static provisioning. So similarly, delete means the volume snapshot content, and the snapshot on the storage system will be deleted when you delete the volume snapshot. And retain means when you delete volume snapshot, the volume snapshot content will be left on, and admin can delete it later. It can create a new volume snapshot content to associate with that snapshot on the storage, and then that can be bound with a new volume snapshot at a later time. API, we have a volume snapshot class. Volume snapshot class is similar to the storage class. So we have a deletion policy field there. So this is used for dynamic provisioning, the volume snapshot class. And then that is passed to the volume snapshot content spec. The snapshot controller will be checking this field and decide what to do with this content, whether to delete it right away or leave it alone, and then admin can decide what to do with it if the policy is retained. And so this is the details of a volume snapshot content. So the deletion policy is delete here. So this is all for the volume snapshot content and persistent volume reclaim policies. And then, so for the future, we are looking at setting a policy to periodically creating snapshot, maybe do it nightly or weekly at a certain time. And also we can have a retention policy, so we can keep the snapshot for a certain duration, or we can delete it automatically if the total number of snapshots reaches a certain number. So this is something that we are just thinking about for the future. I was actually just looking at your agenda before this meeting. I see that you have some proposals such as a topology, service topology. That's also is that right? So that's something that you consider as a policy as well, the topologies?
Yeah. So that one that one was for the SIG network, I think.
Okay.
Yeah.
Because I just saw that one right before this meeting, because we actually also have topologies. I did not include in the slides. We do have topologies for the volumes. So in the storage class, you can also specify a lot of topologies. And then there's a flag called volume binding mode. Then if you set that to wait for first consumer, then the scheduling of the volume will be delayed until the pod is trying to use a volume. So the scheduler actually will be looking at the storage class and look at the topology information, and then choose a node that is appropriate. And then the provisioner will also be looking at this topology information and deciding whether whether the volume is accessible to a certain node or not. So that's another one. If that's also considered as a policy. So.
Okay.
But we just have not got time to add that here because I just looked at that right before the meeting.
Yeah, there's definitely a area involved with kind of like scheduling, how much it's policy and strictest amount versus matching, if that makes sense.
Mm-hmm.
I know that there's some stuff. We've also heard a lot of needs around kind of like geographic fencing for different volumes or
geographic fencing. What do you mean?
Make sure that certain data stays in countries.
It's like topology concept in general.
Okay.
Yeah, there's just certain on a certain route, the volume could be used or like forbidden.
Mm-hmm. So that there are proposals for those. I haven't heard about those. So I don't
think anything official. Nothing official.
Okay, just somebody
like
mentioned it. Okay. Yeah. So so our topology we basically will specify zones or racks, and then that will, and there is a matching between what we have in the storage class. And then also the node will also have some information about the topology, and then we'll be finding a matching basically. So it's also so this one is actually first implemented in Tree, and then now the topology support is also added to CSI. In CSI, right now it's still alpha, but in the CSI layer, we also have this topology information, like preferred or like requisite topology, and then each node will have like node info will also report topology information so that the provisioner can find a matching. We also thought about that for snapshots, but so far we couldn't find a very solid use case for that yet, because for the problem for snapshot is snapshot is because we use the CRD to define the volume snapshots APIs. So scheduler does not know those CRDs. So scheduler does not know volume snapshot class. So it's kind of hard to add something new for the scheduler to recognize. Right now, scheduler knows the storage class, but to add a new resource there seems to be difficult. So we have not decided what to do with the snapshot yet. So it's kind of delayed.
Okay, so it's more dynamic kind of things.
Right. So basically, for volumes, we already have it. Right? For volume, that's already implemented. For snapshots, so volume already have the topology, because when you create a volume, you usually want to attach the volume. So you do have the node information with it, as long as you delay it until you know the pod want to use this volume, then you would have the node information. The challenge for the snapshot is one challenge is you do not really have a node that you need to attach, and also So there's also differences in different type of snapshots because it depends on the storage systems. For the traditional block storage, the snapshots usually just on the same storage wherever the volume is. So there's really not much choice there. But these days you have a cloud storage. So for like let's say for GCPD and for AWS, EBS, they actually when they take snapshot, they will also upload that one to a object store in the cloud, so that in the GC case, it actually becomes global. But for AWS, so for our project like OpenSDS, we also do this uploading thing. We would upload that to the cloud, and then that would also become global. So it's we couldn't find the same situation as a volume. Well, it's really bound to a node. So that's why when you create a snapshot, the scheduler is actually not really involved, right? So we're still trying to figure out exactly what that means if we want to do the same thing. If we want to get scheduler involved, what that means. If we treat that similarly as a volume, then we would need to bring this new resource to the scheduler. So the scheduler need to understand what is a volume snapshot class. So it's just that there are things that we have not decided what to do yet. So this policy group, it seems like the topic is pretty. It seems to be pretty wide. I see that there are quite different type of topics, right? Like as you mentioned,
Yeah.
scheduler also. It seems to be very broad.
Yeah. So.
Yeah. Right.
Yeah, we touch upon basically everything that has certain aspect of policy. We will try to discuss it. So we have like for policy for authentication, like RBACs, and then for scheduling, that's for the compute, storage, network, and maybe even more. So.
Mm-hmm.
Yeah. So,
Okay.
like, is this the end of the slide?
Yeah,
Okay.
really, I initially thought just in the reclaim policies, deletion policies. Then I thought, okay, topology probably should also be considered a policy as well. So that's not part of the slide.
Okay. So for the
just this last slide, just some things that we may be looking into in the future, but we have not really had any design discussions yet.
Yeah.
Yeah. So that's all I have actually.
Okay. Thank you. So I think one interesting point is the semantic for storage policy is apparently like different from firewall or RBAC that we typically just deal with allowed or not allowed binary options. So I don't know whether it is like similar to network policy that you have to have like specific operations for the policy semantic.
I mean, I think it's similar to networking in that it's a different plane,
Right.
if that makes sense.
Yeah.
So these are all different or orthogonal, what would you call, I guess, eigenvectors of Kubernetes resource types, which, yeah, means also that you have lots of overlapping kind of like how you melt or match everything up together.
Yeah.
So.
Okay. So
are you trying to find a unified way to describe all the different types of policies?
We don't think we can like have a unified way to describe the policy itself, but we are trying to find a way to describe the schema of the policy, meaning like the way to describe the policy description. Because policy description is domain specific, right? If you want to apply policy in like network or storage, the description will be totally different because the environment is different. But the schema, like we talked about during KubeConf, so policy is basically who under what circumstance should do what in which manner, right? This is basically what a policy is. So on that level, we are trying to find if there is a general way of describe the policy schema in Kubernetes that could apply to a wide range of verticals, or if you will, the like storage network. We all have the same way of, who under what should do what. Yeah.
Okay. Yeah, I probably should take a look of your deep dive sessions.
It's a broad topic.
Yep. And so
the reason why we have a working group, but it also means that we get pushed a lot of problems.
So for the storage policy, so the enforcement, the policy enforcement happens on the CSI interface, like actually do the action of the policy.
No, actually, it's in the, if you look at, okay, so let me go back to the slides.
Okay, you can share again.
Okay, hold on. Okay, snapshots actually similar, very similar to the volume. If you look at this one, so these are actually so these are or CRDs in Kubernetes. We do have those in our CSI interface as well. I did not include those here, but it's basically the so you see here it's actually in this okay, let me turn this one. Okay, so volume snapshot content spec, right? So here, so this actually will be passed to the driver, so the driver will know what to do, right? So it is in the CSI as well, but this is the Kubernetes interface. Kubernetes CRD interface has those specified, so it's in the volume snapshot class and also storage class, and then when the provisioner or the controller is the one who decide what to do, and then that will be passed on to the CSI. So when I talked about the topology actually would have a little bit more interface in the CSI. So the topology, unfortunately I don't have a slides here. So that has a field in the storage class, right? So there is a volume binding mode in storage class, and then there is allow topology in the storage class. And then in CSI, we also topologies for the volumes. Volume has there's a requirements. There is a topology requirements. When you create a volume, there is a create a volume request. In that request, you will pass in this topology requirement. What do you want? And then that requirement include a requisite field and also preferred field. And the requisite is actually just whatever is defined in the storage class. We pass that in the requisite field. And then the preferred field, usually we would look at the selected node and then decide what that is. And then And then also when the CSI driver finished the provisioning, we will return a create volume response, and in that response field, we will also have the topology. That will be the final one, right? So the results of this provision volume, what is the topology? So that tells you where this volume is really accessible. And then even in CSI, even in the node info, so for each node, it actually also would return the topology information. So then we can look at that, compare that with the create volume request, and find out what is matching, right? So here's the request. When I create volume, I have this request for topology, whether that matches the topology information in the node. And if it does not match, then that will fail.
Okay.
Right. So it's in both places would have that.
So is it the same case for the PV reclaim policy?
Yeah, reclaim is similar to the this one. Reclaim is similar to snapshot, right? Yeah. So this one basically it's just it will just pass this information to the driver, and the driver will know what to do with it.
Okay.
Yeah.
So that means the enforcement point is the provisioner, basically. The provisioner
right. So
tells the driver what to do, right?
Okay, so if it's topology, that's more complicated because that has the scheduler.
Yeah, I know.
Involved, right? Yeah. So this one is really just the controller. It's mainly the controller will make the decision. So the snapshotter has the snapshot controller, and then for the persistent volumes, if it's an in-tree plugin, then the persistent volume controller will just make the decisions. If it's the external CSI plugin, then that will be handled by the external provisioner.
Okay.
And then in terms of the topology, then scheduler is involved, provisioner is involved, CSI drivers, everything is involved.
Okay, good.
Yeah, now I'm like looking through other questions that people have, and they're like transfer between namespaces, duplicating and copying over these things. There's a lot going on here. That's overwhelming.
Yeah, I think this one is actually, this one also need to, you transfer that. So if you do dynamic provision, for example, you transfer the policy from the volume snapshot class to volume snapshot content spec, right? So that's one. And then if you're talking about topology, then that will be, so a lot of places has that information. Scheduling, you look at that, and the controller, the driver. So it's, yeah.
Okay.
Okay. Do we have any other questions?
Wow. This just seems very complicated. How, like, it's still in alpha, how set are these APIs, or do you think that a lot will change probably?
I think I probably really mixed things up. I probably should. So the claim. So if you look, so because here we're talking about probably three things here, but I only have two things in the slides, right? So I probably mixed things up because I was talking back and forth. Sorry about that. So this persistent volume claim, this is not going to change. This one is already been there for quite a while.
Right,
so the volume claim, yes, this is not going to, shouldn't be changed. This is already released, GA'd. So for the volume snapshot, this whole volume snapshot feature is relatively new. So this whole volume snapshot feature is still alpha. We're trying to bring it to beta. So once it reaches beta, then it will be harder to make any. You can make breaking changes once it reaches beta. But right now, the volume snapshot feature itself is still in alpha. And then the topology I was talking about, so that was actually added in tree first. In tree is already GA'd, but then now we are also adding that support to CSI. So the CSI support part is alpha, so it's very complicated, several pieces.
since we're dealing with volumes and stuff, how does this play in with like the operating system level policies? The app farmer and SE Linux.
This is not going to interfere with those. This is separate. We're just, because the volumes, the storage systems are separate. We are not going to interfere with those.
Any other questions? Xin, could you share this slide and on the meeting note where we can find this slide?
Yeah, I will add that. Yeah, I probably should add this one to Google Slides, right? So then you can have a link there.
Yeah.
Let me do that, and I will add one page for the topology.
Okay. Yeah. Fantastic.
And also maybe I'll add also what is GA, what is alpha, because we kind of have a mixed versions here. It's confusing. Yeah, I will do that.
Okay, thank you very much. Okay, if there's no further questions, I think we can conclude the meeting. And Merry Christmas and Happy New Year to everyone. We will resume probably after the week of the New Year. Okay.
All right. Right.
Holidays. Bye.
Bye.
Bye bye.